in the homework. The first couple things that you want to make sure as we get ready for this test is when you look at question 1 and 2, 1 and 2 are both dealing with your vertex of your parabola. So they're really looking for that highest point. So those two questions are looking for the x of your vertex and the y. The x is how long did it take? The y was what was the height, or your h. Question 3 was really trying to deal with how many seconds till it hits the ground. This is when you are using probably your quadratic formula, and this is when you are setting it equal to 0. So you use that same equation that's up here, except you're going to set it equal to 0. Same thing when I look at number 4, it says how long will it take it to hit the ground? Again, I'm setting it equal to 0. Number 5, when it says how long to hit 112, I should be using the quadratic formula probably for number 4, possibly, number 5. Here you're setting the quadratic formula equal to 0. Here you are setting it equal to 112 to start with. Then you have to finish by hitting that equal to 0 and finishing the question. And then let's see, question number 6, you're looking for when's the maximum height. Again, here you're talking about your vertex. So how long? That's your x of your vertex. That's the negative b over 2a that we are looking at. So looking at those first ones, number 7, again, quadratic formula. Number 8, quadratic formula. Number 9, you're trying to find the maximum height. That's going to be your x of the vertex, that negative b over 2a. And number 10, you think you'd be able to jump looking at that information? Alex.
For 3 through 5, could you factor?
Yes, definitely factor. 3 through 5 definitely could have factored instead of quadratic formula. Actually, much quicker to factor. Yes. Any other questions? Yes. Number 9. All right. So number 9, let's take a look at that one. And I probably, number 3, yeah, you could easily factor that one. You could use a quadratic formula or factor. So number 9 says that you're trying to dunk a basketball. You need to be at least 2.5 feet in the air in order to dunk the ball. So 2.5 feet is an important piece of information. And the height of your feet above the ground is h equals. So if we're trying to find that maximum, we are going to first set it equal, as we are doing it, to 2.5. So we're going to put 2.5, that's my h of t, equals negative 16t squared plus 12t was our equation. The next piece of information that we want to have is, in order to solve any quadratic, we always need it equal to 0. And it's much easier to factor if your t squared is positive. So I'm going to add 16t squared to both sides. I'm going to subtract 12t. Then I have plus 2.5, keeping that positive, equals 0. Could you have subtracted the 2.5 and then factored out a negative 1? That works also, right? Does that make sense to everyone? But it's so much easier if I have a positive out in front here. So once I am looking at this, the next thing says, what's the maximum height? Well, if we're going to find the maximum height, we're talking about the vertex, right? So if I'm looking at my vertex, and again, if you wanted to keep this negative, positive, negative, as you're doing vertex, because then you're thinking of it going down, x is equal to, my x of the vertex is negative b divided by 2a. I got to find the time it takes me to get to that maximum point before I can reach the maximum. So at this point, I have negative 12. So my mistake, I would keep it negative at this point and subtracted that. So keep it negative 12 divided by 2 times negative 16.
So I have 12 divided by 32. If I put that in my calculator, the time is going to be 0.375 seconds. Does that sound right? Okay. Yes.
Answer of that.
Yep. You could have left it as 12 seconds of a second, but that wasn't what they asked us. The question was, what's your height, right? So if we want to find the height in this one, that isn't really my answer. I'm finding h of 0.375. So I'm going to go back to the original equation. I'm going to put negative 16. I'm going to put 0.375 squared plus 12 times 0.375. Am I putting in the minus 2.5? Nope, I'm just trying to see the maximum of that one, which is 2.25. So what's the maximum feet? Your feet are on ground, 2.25. Using that information, will you be able to look at that? Personally for me, never. No matter what. But using this information, no, because it's at 2.5. Yeah.
Can you see number 8?
Number 8. Sure. As we are looking at number 8 says, during World War I, the mortars are fired in trenches 3 feet below ground level. Okay, so when you think about that, here was your, the cannonball is shooting out, but this is 3 feet below below ground, right? This is 3 feet below, is what they are telling us. That cannon is going to go up, okay, and it says the mortars have a velocity of 150 feet per second. Determine how long. So we're going back to that height, h of t, and gravity, negative 16 when you have to write your equations on the test, t squared, minus, then you're working with your velocity, which in this case we have plus 150 t. And since it was 3 feet below, we're going to go with minus 3. As I look at this, I don't even think that's a nice easy one to factor. So I'm going to use my quadratic formula because I'm trying to find when it's going to hit its target or hit the ground, right? So I'm trying to find when it's landing over here after it's shot. So I am going to use x is equal. You guys want to sing it?
No.
Do I have to sing it? Okay, x is equal to, no one's going to sing with me? Negative b plus or minus the square root of b squared minus 4ac. And this is where some of you are not getting this divided by the 2a and making sure you keep that. So in this case, I have minus 150. I'm not going to put all this in my calculator. I'm going to let you guys kind of finish this one. It was plus and minus. You're going to take, I had someone say, can I just put 150, which it was positive, squared, minus 4. So minus my 4. And then I have a negative 16 and a negative 3. All of those being multiplied, subtracted from 150 squared. And then 2 times negative 16. And they're asking you for, what is that variable t? That's our time. So when you get that answer, you should get 2 of them. You can only look at the positive one because we're not like starting below. We're trying to get when it hits the ground. So as you do that one. So if you turn in your notes, so making sure you're looking at the time above as you looked at that. And we are on page, thank you. As you are looking at this page and writing down, so 13 questions as we are looking at your test. Of those 13 questions, I believe our test is 80 points. Just making up my answer key for that, 80 points. That will be your 100%. I can interpret, compare key features of my function. I wouldn't write down all this ELO stuff, but I would write this bold part, and I would also put down what's in red. So, those 4 questions, as we are looking at those, interpreting, that means I can compare the width. I can determine if it's a maximum or minimum. This whole project that you guys have been doing, what you had to do with those cards, I can find the vertex. I can explain the discriminant, positive 2 solutions, negative no solution, 0, 1 solution. And I can work with the 3 forms and change between those. Of those 4 questions, you are looking at about 16 points. The next part says I can solve quadratic equations. Again, when I think of solving my quadratic equations, one of the first things I might be thinking about is looking at a graph. And when we look at a graph, we're talking about the x-intercepts. I might be taking the square roots. I might be factoring. Many of you used that when you did the, like when we looked at the questions in last night's homework, there was like 2 of them for sure that were just like perfect for factoring. And then the quadratic formula. I probably would not use the completing the square because that's almost better for just changing it to another form. So that's more, completing the square wouldn't be necessarily a good way to solve quadratic formulas much faster. And I gotta look at how many points those are in just a minute. And then, so as we are looking at that, I can solve that quadratic by graphing x-intercepts, square roots, factoring quadratic. The next one, I can create and use quadratic equations and graph to solve them. So this is where we're going to talk about identifying your domain and range. Where is the vertex, right? Where's the axis of symmetry? I might have you draw it. And it's also going to be these vertical motion problems, like when does the cannonball get the ground? How much time does it take to get to the maximum height? Anything along that line is going to be in those questions also. I-11. So you start in I-11 with solving with the appropriate method. My hint is, if you can use square roots, that's the quickest way. The next quickest is factoring. Most of these are not graphed, right? So I probably wouldn't graph them because you don't have a graphing calculator that you should be using. So when I take a look, I am always going to look as setting it always equal to 0. So whenever you're solving an equation, equal to 0, except if I just have x squared in a number, right? Then I might set the x squared equal to the number and take my square root. Oh, should I, when I look at question 3, multiply that out because it's already factored for me if I am solving? What do you think? Should I multiply it and get it to look like number 2 or like number 4 when I look at number 3? No, huge waste of your time. You're on the test and you have 2 things already factored. You're like, Mrs. Thompson, that was so nice of you. I can't believe you just asked. Because what are you going to do? You're going to put x minus 1 equals 0, and you're going to put x minus 10 equals 0, and you are going to solve for x, and you're going to give me your 2 solutions. So if it's already factored, you're like, that is the best deal ever, right? Because you're almost done with the problem. There are some of them you might try to factor, and after you work at factoring a while, you get stuck. Go to quadratic formula, right? Use that quadratic formula. Make sure you have the formula right. Some of you are making a mistake not writing the right formula. Okay, so if you don't have the right formula, it's really going to mess you up. So you look at I-11, and as you're looking at that page, it's pretty much all solving. Then you go into this next one, how many real number solutions. What are you looking at to find how many real number solutions? The only thing I really care about, so turn to page 56, is it? On that bottom half, page 56, what is the only thing I care about to know how many real number solution? I'm looking for the what? It's in my quadratic, it's special. Tells me the number of solutions, called the discriminant. I need to look at the discriminant here. What's the discriminant? That's your b squared minus 4ac. Do I ask you to solve it? Nope, I just want to know the number of solutions. I'm going to do something similar on the test, right? I'm just going to say how many solutions. You're going to look at your discriminant as you are looking at that. So that's what you're doing on those bottom three questions. As you look at the top of the next page, you're doing graphs. My suggestion when you do a graph, you might think of that parent function. You might think, okay, I know the vertex. You can think of vertex form. If you want to change it to vertex form, you could. But remember, if you make a table of values, your vertex should be in the middle. This is going to be your middle value, so that it is symmetric. You have many ways of finding the vertex, right? You could rewrite it in vertex form. You can go x equals the negative b divided by 2a, so there's many ways of doing that. So you are graphing, I think there's just 4 graphs. Yeah, and then we talked about the progress, so that will come up tomorrow. So